Today I'll be demonstrating to use some soap-powered boats. The explanation for how this process works will be after the demonstration. So as you can see before you, I have a bunch of different papers right now with me, and as you can see they all have a little hole that I used a hole puncher to punch in for these holes. As well, you'll notice that they all have these two lines going down. Two lines going down from that hole to the edge. It's very important that you have this little line. I will be explaining that later as well. So here's some of the designs that I drew up. You can do anything you want for the upper design. And here's some that I cut up, as you can see. You know, they still have that circle from the hole punch, and they all have that little straight lane going from the hole punched hole to the outer edge. That's important. Alright, that's it for the paper. What I have next is a big glass bowl. The bigger the bowl, the better. So for reference, in comparison to the boat, this is the bowl, this is the boat size. You know, the bigger the bowl, the better the effect you will get for the experiment, because you will be able to see the boat travel a further distance. What's next is just any sort of dish soap. I'm using palm oil or palm olive. This is critical for the experiment. And in combination with the dish soap, I just have it in a nice little container so it's easier to use. And lastly, I'm using a chopstick. You don't have to use the chopstick, you can use a toothpick or any sort of small dipping device. I'm just using the chopstick for reusable, sustainable reasons. Yeah, that's it for the materials. Let's get on to the experiment. So just to demonstrate what I'm doing off screen, because you won't be able to see this once the big bowl is back in view. So this is the dish soap. I'm taking the chopstick. I'm going to be dipping it into the soap. So as you can see, it's carrying some of that dish soap. You don't want too much, but you don't want too little either. Right? You can see that. So that's what I'm doing off screen with the dish soap. Here's that big bowl. Right. Here's my boat. So what I will be doing is I'll be dropping this boat into the water, and just notice that, you know, what it's doing. Nothing's happening, right? I'm going to drop it, boom, it doesn't move. It moves with the waves, maybe. What I'm going to do is now take some of the soap, make sure to only dip it into the circle of the boat, and as you can see, boom, there it goes. Yeah. So that is the soap-powered boat. You can see that it propelled itself. And you might be wondering, why is that the case? And that's what we're going to explain next. So in this picture, there's just a bowl of water and the paper boat. In this case, all the water molecules form a thin layer using the power of surface tension. And surface tension is actually what is keeping this boat afloat. So in this case, when there's only water molecules, they're all quite content with each other. You know, they're really cohesive and just one whole layer. But what happens when we add soap to disrupt it? So here we have a picture of us adding some dish soap to our boat, and I'm going to emphasize why we added it just to the center of the boat. Because what happens when you add dish soap to this system of water, we described that all the water forms like a single layer using the power of surface tension. What happens when the dish soap comes in contact with the water, though, it will disrupt that single layer. Instead, what happens, the dish soap will make certain areas of the water have lower surface tension than some other areas which will have higher surface tension. So in this case, surface tension does work in a gradient. Liquids of lower surface tension like to go to areas of higher surface tension. So as we mentioned, adding soap will cause things to have a lower surface tension. So therefore, the water that is inside the boat, in that circle where we added the soap, that has lower surface tension. Therefore, that low wants to go to the high. So the water will push out from the center to the high surface tension in the surrounding bowl. And that's what propels the boat forward. Now you might be wondering, what happens if we add some more soap or take another boat and see what happens? Right, so here's another boat. Just gonna drop it in. And again, taking the soap, just a little bit, Make sure it only goes into the center. Like so. And as you can see, nothing happens, which is a bit odd. So that we'll be also talking about. So why doesn't the second boat move? That's something that you may be thinking about. So one unfortunate thing about this experiment is that it's a single-use experiment. So after every single experiment, you have to clean the whole thing. Why is that? Because again, remember, soap will cause lower surface tension where it's added. And what happens after the first boat, where you already added soap to this bowl, what happens is the soap will disperse, and slowly that entire bowl will be just a mixture of soap and water. So that's why when you're in the second time, when you're adding soap, well, you know, there's no more lower or higher surface tension. Everything's the same. Everything's now soapy water. So that's why it doesn't get propelled forward like the first boat. So the whole process of something going from a lower surface tension to a higher surface tension is called the Maragoni effect. And we use that Maragoni effect to propel our boats. I hope you enjoy the experiment and try it at home.